first thing we can do is look at the correlation. As we have discussed this before, df.core will actually give us a correlation matrix. As you can see, that it's going to be a square matrix of all of the fields that you have, numerical fields that you have in your original data frame. So correlation is going to range from -1 to 1, and then we can actually convert this into a heat map for visualization purpose. You can see that in diagonal, because it's a correlation to its own, it's always going to be 1. However, we do see some darker places like here and here to tell you that these are highly correlated features. Estimated value to number of bathrooms definitely has very high correlation. So now, what is the difference between covariance and correlation? Covariance is the unstandardized form of correlation. So correlation is derived from covariance. You will get the covariance first and then standardize it so that it becomes from -1 to 1. However, covariance can be anything, but it captures the variance of the relationship between the variance of one features and another features. So you can see that this is my covariance matrix. It can be anything. It doesn't have to be from -1 to 1. This number is very big, right? You can actually see it's like it has like 7 zeros. So definitely looking at this to determine which features to use, I will typically look at df.core, look at the correlation, and then right now my predictive, my target variable is estimated value in this data set. Therefore, I want to look in this column, the last column, and pick the ones that have the highest correlations. For instance, the number of bathrooms, square footage, prior sale amount. All these are good features. So that's when we want to look at correlations and covariance. And also, the other one is detecting outliers. So when we're trying to look at a new data set, we want to have a good understanding of what the outliers are. So remember we talked about the linear regression model in a previous video, which can be distorted by a few outliers because we're trying to fit a line into a data set, into a given data set. And then if we do have few outliers that are far away from the majority of the data points, then it is likely that this line that we're trying to fit gets lifted or by these few outliers. That's why you need to be careful, and then you want to either drop them, remove these outliers, or impute them using your average, median, right? So first of all, let's take a look at how we can determine the outliers, how we can detect the outliers, how we can remove them. So remember, X is what we have used as our feature matrix. So we have all these 7 features, and what we're trying to predict is Y, right? Is our estimated value. So we can actually reassign this. Okay, so Y now is going to be our the estimated value of a property. So now let's look at the columns, right? We have, this is a good function, a very convenient function. You just do df or x dot columns, and you get all the columns. For all of the column header, so I want to loop it through to get the histogram, right? So that's what I'm actually doing. And then also print out the mean and then standard deviation, right? And then really show the histogram. So as you can see, right, starting from the top, so the number of, this is bedroom, is centered around 3, right? And then it has some like normal shape. So what I can see is if it's above 6 or 7 or 6 or 7, that's where I can draw the line, right? And say that's outlier.